Sweet. Just so they can hear me better. I really don't know. It's all good, though. All right, so be on page 193. This question isn't on page 193. I'm reviewing a little bit before we get to page 193. So this question asks, what is the pH of a solution of 0.03 molar HCl? So it wants to know the pH. It gives us 0.03 molar HCl. Now, first thing we want to figure out, this molarity that we're given, this solution molarity, is this an acid or a base? Acid. Acids break apart into which ion? Hydronium or hydroxide? Hydronium. So we know the hydronium hydroxide, the hydronium concentration just by looking at that molarity. So what is it? 0.03. Oh yeah, it does. My grammar looks it's real good right now. What is the pH of a solution of 0.03 molar? So since there's only one H, it will just break apart into one H plus, forming one hydronium. So that's why we can keep the same molarity. If there were two hydrogens, two H pluses, we would multiply this number by 2. Okay, now pH. We only have 2 equations so far. Which one of these equations will help us solve for pH? Second problem. pH equals negative log of the hydronium concentration. Do we have a hydronium concentration? Yes, we do. So what do we do with this 0.03? Plug it in. So pH equals negative log of 0.03. So in your calculator, there should legit be a button that says log, log. Hit negative, then that button, and then rock and roll. So did anyone else get 1.52? Yeah, 1.52? Because I didn't do it in my calculator. I'm trusting you guys. So this is the right answer. So the pH equals 1.52. Does pH have a unit? Nope. And 1.52, is that an acidic or basic pH? Acidic. Remember, less than 7, acid. Greater than 7, base. 7 exactly, neutral. All right, HCl, is that an acid? Yeah, good. It has a hydrogen. This is an acidic pH, so we're good. Okay. So now we have this equation to find pH using our hydronium, but the hydroxide ion feels a little left out. Right? So there's actually an equation similar to pH that involves hydroxide. So we can find something called pOH. I'm separating last class's formulas from this class. pOH by taking the negative log of, what do you think? Hydroxide concentration. What? And this is my favorite equation of all the equations. It's just so handy. If you have a pH and a pOH, they add up to equal 14. What? So say they were like, what's the pH? But you only have a pOH. You can plug in the pOH and find it. So we're going to practice doing a little bit of that. So here comes a couple more made up problems by me. So what is the pOH of 1 molar? All right, so what is the pOH of a 0.11 molar SrOH2 solution? So in order to find pOH, what equation should we use? pOH equals what? Negative log of hydroxide. Right? Can we find hydroxide? We have a strontium hydroxide. Yeah. So my OH concentration, how many hydroxides will this break apart to in solution? 2. So what do we need to do this number? Multiply by 2. So 0.22 molar is our hydroxide concentration. Is that our final answer? No. It asks us for the pOH. But is that what we need to plug into that pOH equation? Yes, that first one. So pOH equals negative log of the hydroxide concentration. Negative log means you hit the negative sign in your calculator, you hit log, and then you enter the concentration of hydroxide. Yeah, good question. So, negative log of what number? 0.22. I'm going to get the calculator that I like. So negative log. If you're struggling to find the log in your calculator, please do let me know. Please don't be on your cell phones during this very important instruction time. All right, so what is the pH? Or sorry, the pOH? 0.66. That's a small number. All right, so just like pH, pOH is unitless as well. So pOH is 0.66. Now, what if I wanted to extend this question? I'm like, okay, so the pOH is 0.66. What is the pH? Then this beauty right here would come in handy. So, what? Right, so if you have pOH, I would always convert it to pH to compare the way that you're trying to compare. Otherwise, you're going to get confused. I promise. So, again, our pOH is 0.66. So, if I'm asking you for a pH, which if we have pH, we can tell. Is it acidic? Is it basic? That's the easiest way to compare it. So, I'm just going to plug it into this equation, which in order to get pH by itself, you do what? Subtract the 0.66 from both sides. So, the pH is what? 13.34. Right? Got that answer, got that answer. Now, pH will help us check our answer. What is this? Strontium hydroxide, acid or base? Base. Is that a basic pH? It is. All right. Any questions on this? If you guys have questions, please do ask. But it's really hard for me to answer a question that just says, I don't understand. I'm like, which part? If you have like a specific question, like, how did you get that number? How did you do that? Those are helpful for me helping you. Help me help you. Yes, Jared?
So, like, H3O and OH, those are always times pOH times 2?
Are you talking about what we did up here? To find, it's not always times 2. It just depends on how many OHs or H's you have. So since there's 2 OHs, that's why we multiplied that by 2. If it had only been 1 AH, we would have just kept the 0.11. Good stuff. Good. You're welcome. All right. I'm going to hit you with a different question. It's helpful to write down the questions that I write so that when you're going back into your notes, you don't just see work, you see the question and the work, so that you can apply it to questions you're answering for your homework. All my markers are like dying. What? Of a 1, 2, 3, 4. So what is the pOH of a 0.034 molar HBr solution? Try to solve using the equations that we know so far. Which also, you'll find that these problems that we start doing, there's multiple pathways to get to the right answer. So if on your quiz you solve it different than someone else, but you get the same answer, you're good to go. You're just creative. What is the pOH of a 0.034 molar HBr solution? And there's two ways that I see you can solve this one fairly simply. Remember, you can use equations from last class if you desire as well. All right, so can someone explain to me how they went about solving this, or how they would go about solving this if they had time to finish? Yeah, Jorge?
I found out the pH first.
Okay.
With pH equals negative log
Yeah.
times H3O.
Sweet.
And knowing that, just the pH plus pOH equals 14.
Wonderful. Sweet. So he realized that, hey, what do I have here, acid or base? Acid. So do I know the OH concentration from that? No, you know the hydroxide concentration. H3O plus. Right? How many H's? One. So we keep the concentration the same. It's only going to break apart into one H3O plus. All right, so he's like, hey, I can't plug that into my pOH equation, but I can plug it into what equation? pH. So I could find the pH, and then I could use this to solve for pOH. If you did it different, but got the same answer we're about to get, rock on. Okay. So pH equals negative log of this. So plug that in if you didn't already, or if you didn't already solve it. So what did you get for your pH? 1.4 and 7. I'm going to leave it to 2 after the decimal. Now, is that our final answer? No, because we're looking for pOH. So now we use the fact that pH plus pOH must equal 14. So we just take 14 minus 1.47, and your pOH equals what? 12.53. Answer. If you wanted to double check your work, look at the pH. Is that an acidic or basic pH? Acidic, is that an acid? Yeah. We're good. Now, some of you might have done it a different way. The first way I was thinking is, hey, we can get this H3O plus concentration. What can we solve for with this equation? OH, and then you could just plug that straight into your pOH. So either way, it's good to go. Some of you might have thought of it that way. Questions on this one? Just started graphing something. Any step where you're like, how did you get that? Crickets. Okay. All right, well then let's look at our final two equations. Bum, bum, bum. And we're actually just using these two equations, and we're rearranging them. So let me erase this and then we can get started. Now we're going to actually be looking at page 193. So what if I gave you a pH? I said the pH is blah, blah, blah. I need you to find the hydronium concentration. So I give you a pH of like 8. And then I'm like, hey, solve for the hydronium concentration. Would you guys know how to get the negative log away from the hydronium? Well, log dividing is not its opposite function. So we know that the opposite of addition is, the opposite of multiplication is division. All right, well, the opposite of log is called anti-log. It's the scary brother. You guys have probably done it in your math classes, but yep, you just hit second in log. So a lot of you, your anti-log in your calculator looks like 10 to the x. Yeah. So look at your log button and see if right above it is like a little 10 to the x. Yep. Okay, that's your anti-log. Anti-log is 10 to the x. So I'm going to rearrange the pH equation to show you how we rearrange it, and then you'll just have the equations to use. There you go. All right, so negative log of hydronium. All right, so again, the goal is we've been given a pH. We want to solve for H3O+. First thing we want to do is get rid of the negative sign. Move it to the other side. And what's technically here? A negative what? Not a negative 10, but a negative 1. All right, so if we divide both sides by negative 1, I'm not going to make you guys rearrange this for a test. Right. But it's helpful to know how to do it. So then I would have negative pH equals log of H3O+. All right, so I got the negative sign away from it. Now, again, how do we get rid of log? Anti-log. So sometimes you'll have anti-log written. I like to write 10 to the log power. So then what you do to one side, you must do to the other. Anti-log and log cancel each other out. So our equation to solve for hydronium is anti-log to the negative pH. So practice on your calculator. Let's say our pH was 7. So go second log, or wherever your anti-log is, to the negative 7th. And tell me what you get for your hydronium concentration. 1 times 10 to the negative 7th. All right. Do anti-log. What about for a pH of 2.5? So you would have to type in 0.00316. So again, if I gave you a pH of 2.5, you would just 10 to the negative 2.5 and solve your anti-log. It's like 0.00316. It might have given it to you in scientific notation. All right. So I'm going to add this equation over to our friends over here. I'm going to put it right beside the pH equation because that is just the pH equation rearranged. So these two are like sisters. Negative pH. So your anti-log to the negative pH. So then what do you think this equation is rearranged? What does hydroxide probably equal? To the 10 to the, yeah. So anti-log to the negative pOH. Whew. right, so these 6 equations, those 4 and those 2, are all of our equations for this mini unit. So let's practice using them. Let's practice using our anti-log one. What? Oh, just kidding. There's questions in the book. All right, let's look at A, 6A. It says, what is the hydroxide concentration if a solution has a pH of 9.95? So I'm going to list out what I'm given. Has a pH of 9.95. And we're trying to solve for a hydroxide concentration. So, what can we solve for with a pH? Looking at our new blue equations, if we plug into pH to one of them, what are we solving for? Yeah, hydronium. So if we plug in a pH, we can solve for hydronium. And then we can eventually get to hydroxide. All right, but what if we just want to get straight to OH? What would we need? pOH. Could we get pOH pretty easily from pH? Yeah. We could do 14 minus 9.95. All right, so what is our pOH? What's 14 minus 9.95? 4.95. Sweet. So now we can plug that into here, and we can just go straight to our OH negative. We don't have to worry about getting hydronium and then plugging it into here, even though you would still get the same answer. So, hydroxide equals anti-log to the negative what? 4.95. All right, solve. Solve. Oh, it is 4.05. 14 minus 9.95 is 4.05. Maybe I heard someone wrong? I don't know. Thanks, Janet. What is it? Go get a drink of water if you need it. All right, so my calculator gives it in scientific notation form, 8.91 times 10 to the negative fifth in its concentration, so molarity. 0.00891. I would still take it in that form, but it's just kind of obnoxious. See how much nicer that is? Yeah, but either way, it's the same thing. Questions? Sometimes you guys are so silent, and I'm like, do they not understand any of it? Am I going too slow and they're bored? Because they just understand it so well? If you don't ask questions, I won't know.
What?
It's all good. All is well. Okay. Stop, guys. Stop. All right. Go ahead and try to solve B. Go for it. Solve B by your lonesomes. Letter B. Number B, yes. I like to say number B as well, because why not? Number B. People People snatched them up. People snatched up my crappy calculators. Amy, don't die on me. Thanks, girl. I know this one. Which one? Which one? This. Huh. Huh. Oh. This one? This one? Okay. So we can solve for hydronium. All we need is a what? pH. Do we have pH? Hallelujah. All right. So antilog to the negative. Don't forget the negative. 12.25. So second log negative 12.25. Again, if you're not getting the same answers as me on the calculator, let me help you with your calculator. All right, so what's our hydronium concentration? 5.62 to the negative 13th. And this is a concentration. What do we need? Molarity. I can guarantee some of you are going to forget to put M on concentrations on your quiz. Don't do it. Don't do it. pH is labelless, but molarity is not. Ooh, ooh. Any questions on that one? Yay. That makes sense. That's what I like to hear. So solve E. Solve E, and then we'll move on. Yep, I'm skipping them. Skipping CD and going to E. Does anyone have CDs anymore? Yeah, sweet. Does anyone use their CD player in their vehicle? Look at this photograph. No. I can't even do the Nickelback voice. Look at this photograph. All right. That's pretty bad. No Nickelback hating. I'm old. Hey, solve these with us, then you'll have no setback on your homework. It's okay. I doubt that many people are actually watching this anyway. Was I a singer? I like to sing, but I didn't do it in high school because I didn't have enough, I had too many other classes to take choir, but I do like to sing. I don't usually hit you guys with my real voice. Usually you get my fake voice. If I sing in my real voice, you guys would just drop dead and be like, oh. Just kidding. I'm kidding. It's really not.
What Noah said.
Like, what did Noah say?
Drop dead good or drop dead bad?
That's up to interpretation. Okay, guys, so we need to solve for OH, the hydroxide concentration. There's a couple equations that help us solve for OH, like we could use this one, or we could use this one. Which one do you guys want to use? This one? All right, to solve for hydroxide, what do we need to know? pOH. How can we get pOH from this? Subtract from 14. So what is it? Okay, so that is our pOH. So then we can use our anti-log equation. To the negative 9.10 for our pOH. So our concentration of hydroxide, Isabella, you can't tell.
7.94 times 2.
To the negative 10. And what do we need? And what? Mole? Not mole. Molarity. Molarity. Okay, guys, so your homework for tonight is pages 197 to 199, 7 through 23. If you were gone last class, if you do 1 through 23, you're going to cover what you missed. Yeah, you can turn that off. Also,